Hello, 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 my dear students. You're very welcome to today's lecture. This is lesson number 6, problem set number 4 of dimensional analysis. And I'm your personal physics tutor, Dr. Rima McMullen. This lesson is a continuation of the previous lessons where we were solving previous year's problems from JEE and NEET kind of exams. Alrighty. So, without any delay, let's dive right into today's problem number 1. Problem number 1 is based on this equation. What is this equation? This equation is the equation of state of a real gas. And you see these symbols here, P, V, R, T, A, B, blah, blah. What are these things? Let's look at that. R here is universal gas constant. What does it mean? Let's not worry about it yet. T is the temperature. V, which appears at two places, is the volume. P is the pressure. But that is not it. We have this A here and this B. And A and B, these are two constants that have dimensions. So the first problem is based exactly on the same thing. It says that the ratio of the constants A over B is dimensionally the same as that of PV, P over V, V over P, or P times V cubed. What does that mean? Our equation is P minus A over V squared times V minus B equals RT. This equation has two expressions, A and B on the left-hand side, that are being multiplied together to give you RT on the right-hand side. Now, according to the principle of homogeneity, yep, again, that same old principle. According to the principle of homogeneity. Now, what does the principle of homogeneity says? Tell me in the comments. Alrighty. The principle of homogeneity says that in an equation or an expression, the units or the dimensions of every single term are equal to each other. Let's apply principle of homogeneity to expression A. Expression A says A is equal to P minus A over V squared. Now, applying the principle of homogeneity, we'll see that the dimensions of A equals dimensions of P, which is equal to dimensions of A over V squared. Now, this A on the left-hand side, this is just an arbitrary name that I gave to the expression P minus A over V squared. So the dimensions of A are irrelevant to us. However, using principle of homogeneity, we will say that the dimensions of P is same as dimensions of A over V squared, which is same as dimensions of P equals dimensions of A divided by dimensions of V squared. Now go ahead and multiply both sides of this equation by V squared. What does this give you? V squared cancels out on the right hand side. And now if you swap left and right hand side, you will get the dimensional formula for A equals dimensional formula for P times the dimensional formula for V squared, which is same as dimensional formula for P times dimensional formula for V and the square of this dimensional formula. Or if you wish, you could write this as PV squared's dimensional formula. Why am I writing all these different ways? Just to show to you that these are all equivalent ways of saying the same thing. Now we know the dimensional formula for A. Next, we need to know the dimensional formula for B. And to do that, let's see. We're going to now look at the expression B. Let me draw a line here. Alrighty. So B, the expression B equals what? It equals V minus B. Again, utilizing the principle of homogeneity, we'll say that the dimensional formula for B is same as the dimensional formula on the right-hand side, which is V minus B. Applying principle of homogeneity to this expression V minus B, we will say that the dimensional formula for V, the volume, is same as that of B. And then that is it. Here we got the dimensional formula for B. Now we want to find out the dimensional formula for A over B. All right. So here's the A over B's dimensional formula is same as dimensional formula for A divided by dimensional formula for B. Dimensional formula for A is equal to dimensional formula for P times dimensional formula for V and the square of that. And the dimensional formula for B is equal to dimensional formula for V. Now right away, I'm sure you see that this dimensional formula for V at the bottom on the right hand side cancels out one of the dimensional formula for V at the top. What does this leave us with? This leaves us with A over B's dimensional formula, okay, that's not fitting, is equal to dimensional formula for P times dimensional formula for V, which is same as the dimensional formula for product of PV. So here, let's box it in. Why? Because I like to do so. What did we get? We got the dimensional formula for A over B. A and B are two constants. What are we asked? The ratio of the two constants A over B is dimensionally same as that of, our options are 1 PV. Well, that happens to be correct answer. Shall I stop there? I got my answer. No, do not stop. Why? Because many times they will give you more than one correct answer. Therefore, even if you see that the first one is the correct answer, you have to look at options B, C, D, or option 2, 3, 4, 5, however many number of options are there, because you may have more than one correct answer. So let's look at answer number 2. P over V, definitely not. V over P, PV cubed, nope. So in this case, the answer was just 1, and that is answer number 1, the option number 1. So here you go. We have solved for the first problem. Here's your solution. Looks pretty cool, doesn't it? Alrighty, moving on to problem number 2 next. Problem number 2 is based on the same equation, which is P minus A over V squared times V minus B equals RT. Here R is the universal gas constant, T is the temperature, P is the pressure, and B is the volume. And A and B, these are constants that have dimensions. And in problem number 1, we evaluated the dimensions of the ratio A over B to be P times V. In this equation, we're asked to find out that the dimensions of A over B is equivalent to which of these following? Force, impulse, energy, or pressure. So let's go ahead and solve for this. The pressure P, let me use a different color for P here. Why? Just to make it fun. P, pressure equals force per unit area times V is for volume. All right, let's close the parentheses. Now, you do know that, all right, let's come down here. Force over area. If you write in terms of the dimensions, then the area will be M0, L2, T0, right? Now, M has power of 0 and so does T. We do not need to write it. So I'm going to write just L squared for A. Similarly, for volume, in volume you multiply 3 lengths together, height, length, and width. So volume will have units of L cubed, correct? Now what does this give you? L squared at the bottom cancels out L squared at the top. That leaves you with F times L. Do I need to go further? Force times displacement, cosine theta. Okay. FD cosine theta is nothing but work. So if you knew that much, then you know that this is work. In other words, this is energy. But let's say you didn't remember it. Then in that case, what you will do is you will plug in the either the units or the uh, dimensions of F and L. F is M1 L1 T minus 2. Okay, so this is your F. Now, once again, you should probably memorize this. Normally, I don't recommend memorizations. Anyway, I really do not think that there's any need to memorize it because force is mass times acceleration, and acceleration is meters per second squared. So here's mass times meter L1 per second squared t to the negative 2 times this L. This L is m0 L1 t0 parentheses closed. What does this give us? M1 times M0 is M1, L1 times L1 is L2, t to the negative 2 times t to the 0 is t to the negative 2. And this is the dimensional formula for energy. But let's say you don't remember that. Then what you could do is, this is mass, correct? And L squared times t to the minus 2 can be written as L1 t minus 1 to the square to the power 2. Now L1 t minus 1, this is velocity. So here, this gives you velocity squared because L squared t minus 2 gives you v squared. And except for a factor here, which could be 1/2. This is kinetic energy. So here, there are multiple ways of solving the problems. And the more you understand the concepts, the easier it is for you to solve the problems. So solve as many problems as you can, take notes, write with your own hands, and you will see this is going to become easy as time goes on. So let's look at the options now, the answer choices. Force. Well, we got A over B to be, not. We saw that, we just saw that we got A over B, this to be FL, correct? So this couldn't be force because this is force times distance. Impulse. Now you have not seen it yet, but impulse is force times delta t. But we have force times distance here, so impulse is not correct answer. Energy, yep, we just saw that energy is the correct answer. Could it be pressure? No, because A over B's dimensional formula is equal to P times V. So it is not just P, but it is P times V. Therefore, option number 4 is incorrect as well. So answer is number 3, which is energy. Here you go. Problem number 2 solved. Not too bad, huh? If you know how to solve it, it isn't bad. Let's move on to problem number 3 now. Problem number 3 is based on the same equation, which is the equation of the state of a real gas. P minus A over V squared times V minus B equals RT. In this problem, we're asked to find the dimensions of the ratio A over B squared. And we're asked if that ratio is equivalent to R, P, RT, or V. So we already know that the dimensions of A are PV squared. And we also know that the dimensions of B are simply V. Let's go ahead and divide these equations and square the bottom. So what does this give us? PV squared divided by V squared under the parentheses cancels out V squared, right? What are we left with? Just P. So the dimensions of the ratio A over B squared is equivalent to what? Just P. So the answer is P. So answer is 2P. This is your answer. Or I should say it is your correct answer. It could be wrong answer, right? We don't want wrong answer. We want correct answer. Let's move to problem number 4 now, which is based on the same equation, but you will see that it has a twist. Problem number 4. The dimensions of the ratio B squared over A is equivalent to which physical quantity? So in problem number 3, we figured out the dimensions of A over B squared to be pressure. Now in this problem, we're asked about the dimensions of B squared over A. So all I need to do is just flip P. It gives us 1 over P. Dimensions of 1 over pressure is equivalent to energy density, modulus of rigidity, bulk modulus, or compressibility. Okay, so let's look at this for a second. Pressure is force per unit area, correct? So this will give us the 4 dimensions of B squared over A to be L squared at the top, M1, L1 T minus 2 at the bottom. What does this give us? M minus 1, L1, T2. These are the dimensions of 1 over P, also of B squared over A. All right, so now we need to figure out of these 4 options, which one or which ones are the correct answers. So first one is energy density. I'll have to look at all the answer choices here. Energy density. This is energy per unit volume. That's what energy density means. Energy is same as work, which I know is M1 L2 T minus 2, and volume is L cubed. This gives me, this is going to be wrong answer. I don't even need to go any further than this. Why? Because in the answer, I'll have m to the power plus 1. Do you see that? However, my correct answer should have m to the power minus 1. So if you want to solve it further, be my guest. M1, L minus 1, T minus 2. So energy density is not the correct answer. Modulus of rigidity. What is that? Modulus of rigidity. So it is the stress over strain. Okay. So stress over strain. What is stress? Stress is force per unit area. Okay. That is your stress. And strain is change in length per unit length. Just want to bring this equal sign down. So if you see in terms of the dimensions, then the modulus of rigidity, let's call it m for now. M. The dimensional formula for m equals dimensional formula for force per unit area divided by delta L over L. Delta L is the change in length, right? You know the symbol delta, like a triangle, it means change. It means change in length. And at the bottom I have length. So delta L and L both have the same dimensions, same units. Therefore, the dimensions cancel out. And I'm left with the modulus of rigidity equal to the dimensions of force per unit area. Force per unit area is pressure. However, in my question, the B squared over A, this is what I'm working on, right? B squared over A, the dimensional formula for B squared over A is 1 over P, not P. So their modulus of rigidity is not the correct answer. Okay? I understand that you have probably most likely not seen what's modulus of rigidity, what is what I'm about to talk about, to bulk modulus. But don't worry, we'll work on all these things when we get to properties of matter, which won't be too long from now. Bulk modulus is the resistance of a substance to bulk compression. Resistance of a substance. Oh, promise I know how to spell substance. Substance to bulk compression. All right. And let's use letter K to represent bulk modulus. And it's defined as negative V dP over dV. Don't ask me where it comes from. I'll go over this when we get to the chapter on properties of matter. Now is not the time to do that. Now is the time just to see how to solve these problems given the formula. Hopefully by the time you're taking this test, which might be the end of the year exam or your NEET exam or your JEE exam, I really want to call JEE as G. Let's call it G. Okay. By that time, hopefully you will know these formulae by heart. I mean, you should if you want to ace the exams. Talking about the dimensions, negative sign doesn't matter. And look here, this becomes V, this V times dP over dV. Now, if we talk in terms of the units of V and the units of dV, dV is just the change in V, the volume, are going to be same. I mean, if the dV is, let's say, the volume changes from 10 liters to 8 liters, dV is what? dV is minus 2 there. The change is always final minus initial. If the initial volume is 10 and the final volume is 8, then your dV is negative 2 liters. And V at the top could be 15 liters, 20 liters, whatever. But the point is that the units of V at the top cancels out the units of dV at the bottom. In other words, I could say that the dimensions of this V at the top cancels out dimensions of dV at the bottom, leaving you with just the dimensions of dP, which is same as the dimensions of P, which is same as what we had for the second option here. That also had the dimensions of P, which was modulus of rigidity. So the modulus of rigidity and bulk modulus have the same dimensions, the dimensions of pressure. But our answer should be have the dimensions of 1 over pressure or pressure inverse. So there you go. 3 is not the answer either. Last is compressibility. What is compressibility? Who knows compressibility? I mean, shouldn't this just be the ability to compress? Beta. Beta equals negative 1 over V dV over dP. And again, don't worry about this. I mean, it is showing you how much the volume changes as you apply pressure. That's what delta V over delta P is. These are curly del's here, okay? And this you use the curly ones, the differentials you use when the function is dependent on more than one variables, or it changes not with just one variable, but with more than one variables. Don't worry about this yet. But anyway, look at the dimensions. That would have dimensions of 1 over V, dimension of del V divided by dimension of del P. So just like before, this V is in liters, del V is change in velocity, not velocity, I mean volume. The change in volume will have the same units as the volume itself does. So volume and the change in volume, the dimensions of these or the units of these, they cancel each other out. And what are you left with? Dimensions of 1 over del P, which is same as the dimensions of what? 1 over P. Your answer is compressibility. And correct answer is compressibility. Correct answer. Huh. Answer is 4, which is compressibility. Problem number 4 done. Moving on to problem number 5 next. Problem number 5. I really do like this problem. Velocity and acceleration in two systems of units are related as expressed below. Okay, let me rewrite this, and I need to make this bigger. V2 equals m over p squared times V1. And A2 is 1 over mp times A1. What are these things? V2 and V1, these are velocities in the two systems of units. V2 is velocity in one system of units and V1 is in the other system of units. Same as acceleration. A2 is acceleration in one system of units and A1 is in the other. Now, example could be like inches to centimeters. You're measuring length. Length 1, length 2. This is L, not 1. This could be in inches and this could be in centimeters. So you could say that length in inches is equal to, I believe, is 2.54 times length in centimeters. Then they're equivalent. So this 2.54 is like saying m over p squared there. I hope you see what I'm trying to tell you here. Here m and p are constants, and unlike the last problem, these constants are dimensionless constants. Determine the relationship between distance and time in these two systems of units. All right, how do we do it? Now, velocity is displacement over time, correct? So for V2, I'm going to write D2 over T2. Displacement in the second system of units divided by time in the second system of units equals m over p squared times V1. V1 will be D1 divided by T1. Now, let's do one thing. Let's have D's on one side of the equation and the T's on the other side of the equation. So tell me if you see what I'm doing. Can you do what I'm doing here? You need to let me know these things in the comments. So I have an idea of like what your level is. Alrighty, so that is that. Now let's look at the equation for acceleration. A2, acceleration is dv over dt, right? And turns out that v is dx over dt, where here x is the displacement. All right, this is d squared x over dt squared. So in this case, I'm using, instead of x, d for displacement, correct? So I will say A2 equals 1 over mp A1. I can write this as A as D2 over T2 squared. Why? Because look here. At the top, I have just x. At the bottom, I have t squared. X is displacement. Therefore, this d2 here, only one of this. It's not squared. While t2 is squared. Why? Because t is squared over here. I hope you see this. Equals. Equals what? 1 over mp times d1 divided by t1 squared. I'm going to do the same thing that I did before. Get d's on one side and t's on the other side. Wow, this is really bad. T2 over T1, and these are being squared. So I could write this as 1 over mp times T2 over T1. This whole thing is squared. Now what can I do? I have these equations here. Let me call this as 1, and let me call this as 2. How about, now 1 and 2 have same expression on the left-hand side. Their left-hand sides are same. So if left-hand sides are same, that means right-hand sides are also going to be same. So let's go ahead and equate the right-hand sides of 1 and 2. Equate right-hand side of 1 and 2. All right, let's do that. That gives me m divided by p squared times T2 over T1 equals 1 over mp times, let me move this up a little bit, T2 over T1 squared, right? Alrighty. So here's what I'm actually doing? I'm now going to divide both sides of this equation by T2 over T1. Okay, that's what I'm actually doing. But I'm not going to write it down here. But however, when I do so, that cancels out this T2 over T1 by the T2 over T1 that I'm dividing it with. And on the right hand side, there are two T2 over T1 that are being multiplied together. One of them is going to cancel with the T2 over T1 that's at the bottom now. Or once you understand that, you see this T2 over T1 on the left hand side and there's square on the right hand side of the same factor. You know that one of these cancels out one of the same factors on the right hand side, provided the same factor is in every single term of the equation. This equation has only one term on each side, so life was easy with this. Not so much at other times, and many students do make those mistakes. But no worries, I'll show you what those mistakes are when we get there. Same thing I'm going to do now. P squared over here, 1p over here, correct? Go ahead and multiply both sides by p. When you do that, it cancels one of these p's on the left-hand side and the p on the right-hand side. Or once you understand this well enough, you see that there's a p at the bottom on the left-hand side and there's a p on the bottom on the right-hand side. They cancel each other out. That leaves you with 1p on the left-hand side and the bottom. Okay. Now, the m here, nothing I can do with this. So I'm going to multiply both sides of this equation by m. Okay. What does that give me? M squared over p equals T2 over T1. Swap left and right if you wish. I wish to do that. Not yet though. Not yet though. Let's leave it. So call it equation number 3. Let me rewrite equation 1. Equation 1 was D2 over D1 was equal to M over P squared times T2 over T1. All right. Now T2 over T1, I have just determined it to be M squared over P in number 3. So what I'll do is, instead of T2 over T1, I'm going to write M squared over P. And my bad, this is not a subscript. It's supposed to be a superscript or a square. What does this give me? This gives me D2 over D1 equals M cubed over P cubed. What does this give me? D2 is equal to M cubed over P cubed D1. So this is the relationship between the distance in the two systems of units. That's what we were asked to find. And the other thing we were asked to find was the relationship between the time. So we got T2 over T1 to be what? M squared over P. This will give you what? T2 equals M squared over P times T1. So this lesson over here is 5 problems. 4 of them are based on the same equation, same statement. In the next problem set, I'm going to bring you more tedious problems. We're going to have more fun. So to solve these problems, you really have to do them on your own. Initially, if you do not know how to solve a problem, it's all right to look at the solution. However, after looking at the solution and after you have made sure that you understand it, close that solution, put it away, and you try solving it on your own. And it's all right if you make a mistake. You compare your solution with the given solution to you. And if you have made any mistake, figure out what mistake did you make and what do you need to rectify it. And after learning that, again, redo the whole problem, solve it again. This is the only way you're going to learn how to solve problems. The more the number of problems you solve, better you're going to become at it. I know I'm being a broken record here, but I really want to make sure that you guys do solve problems, because to tell you the truth, when I was your age, I didn't solve any problems. Nobody told me that the problems needed to be solved. And quite honestly speaking, there was so much syllabus in 11th and 12th that even if I were not solving these problems, I had so much other things to do, It's not like I had free time. But I wish that I was told how important these things were. You're lucky in a way that now there are so many resources available for you and there is so much good advice. And the students who will take the advice, they will be the ones who will actually break the test. They will break it. I mean, they will do so well, they will just break it. All right, we'll see you in the next lecture in which we're going to see even harder problems and even more fun problems. Keep studying, keep working, one problem at a time, one day at a time. See you again next time.